Hello students, welcome to my channel. This video lecture is mainly for B.Sc Mathematics Honours. This is my fourth lecture from the chapter Integers or Number Theory taken from the block Classical Algebra. In this video, we are going to solve a problem applying the principle of mathematical induction. So let's get started. Okay, so here is the problem. Apply mathematical induction to show that factorial n is greater than 2 to the power n, where n is greater than or equal to 4 and n is an integer. That is n equal to 4, 5, 6, ... So in other words, factorial n is greater than 2 to the power n for all natural numbers n greater or equal to 4. Okay, now let's look at how to prove this. We have to prove factorial n greater than 2 to the power n. This is a statement involving n. We can call it Pn. Let Pn be the statement factorial n greater than 2 to the power n. Here we use double quotation for the statement. Okay, now notice that P1, P2, P3 are not true because P1 means factorial 1 greater than 2 to the power 1, that is 1 greater than 2, which is not true. P2 means factorial 2 greater than 2 square, that is 2 greater than 4, which is not true. And P3 means factorial 3 greater than 2 cube, that is 6 greater than 8, which is not true. So P1, P2, P3 are not true. Now what about P4? P4 means factorial 4 greater than 2 to the power 4, that is 24 greater than 16, which is true. So P4 is true. P1, P2, P3 are not true, but P4 is true. Clearly, P4 is true since factorial 4 greater than 2 to the power 4. Factorial 4 greater than 2 to the power 4. Okay. Let us assume that Pk is true where k is a natural number greater or equal to 4. Let us assume that Pk is true where k is a natural number greater or equal to 4. Then Pk is true means factorial k greater than 2 to the power k. Factorial k greater than 2 to the power k. Okay, let's say this is number 1. we are going to use the corollary of the second form of the principle of mathematical induction. We have shown that P4 is true and assumed that Pk is true where k is the natural number greater or equal to 4. So now we have to check whether Pk plus 1 is true. That is whether factorial k plus 1 greater than 2 to the power k plus 1. Okay. Now factorial k plus 1 equal to k plus 1 into factorial k. Can we say this? We know that factorial n equal to n into n minus 1 factorial. Putting n equal to k plus 1 here, we get k plus 1 factorial equal to k plus 1 into k plus 1 minus 1 factorial equal to k plus 1 into k factorial. K plus 1 into k factorial. So we have k plus 1 factorial equal to k plus 1 into k factorial. Okay. Now from 1 we have factorial k greater than 2 to the power k. Multiplying both sides by k plus 1, we get k plus 1 into factorial k greater than k plus 1 into 2 to the power k. K plus 1 into factorial k greater than k plus 1 into 2 to the power k. And this is obtained using 1. Using 1. Okay. Again, k plus 1 into 2 to the power k is greater than 2 into 2 to the power k, because k plus 1 is greater than 2. K plus 1 is greater than 2. How do I get this? Since k is greater or equal to 4, we have k plus 1 is greater or equal to 5, which is greater than 2. Therefore k plus 1 is greater than 2. K plus 1 is greater than 2. Therefore k plus 1 into 2 to the power k greater than 2 into 2 to the power k. K plus 1 into 2 to the power k greater than 2 into 2 to the power k. So we have k plus 1 into 2 to the power k greater than 2 into 2 to the power k. Okay. Thus factorial k plus 1 is greater than 2 into 2 to the power k, which is equal to 2 to the power k plus 1. That is k plus 1 factorial is greater than 2 to the power k plus 1. Okay. So we have factorial k plus 1 is greater than 2 to the power k plus 1. That is pk plus 1 is true. We assumed that pk is true where k is the natural number greater or equal to 4. And now we see that pk plus 1 is also true. Thus pk plus 1 is true if pk is true where K is a natural number greater equal to 4. Okay, so we have shown that P4 is true and Pk is true implies Pk plus 1 is true, where k is a natural number greater equal to 4. Clearly, the two conditions of the corollary of the second form of the principle of mathematical induction are satisfied. This is the first condition and this is the second condition. Therefore, by the principle of mathematical induction, what can we write here? Pn is true for all natural numbers n greater or equal to 4. Pn is true for all natural numbers n greater or equal to 4. That is, Pn is true means factorial n greater than 2 to the power n. That is, factorial n greater than 2 to the power n. And this is true for all natural numbers n greater or equal to 4. For all natural numbers n greater or equal to 4. Okay, this completes the proof. If you haven't watched the video of the principle of mathematical induction, please watch it from the above I button so that you can understand this proof perfectly. Alright, so that's it. If you have any questions, you can ask me freely in the comment section and I'll definitely try to answer them. If you like this video, please click on the like button and also subscribe to my channel for more videos which are important for B.Sc Mathematics Honours exam. And don't forget to click on the bell icon that will give you notifications when new videos come out. So thank you so much for watching and until next time.